Okay, let's get started. Hi everyone, welcome to our two-day workshop on seeking low dimensionality in deep neural networks. My name is Qing, I'm a co-organizer of this workshop. I'm currently a Moon Sloan Fellow at New York University Center of Data Science, and I'm incoming assistant professor at the University of Michigan EECS department. In this brief 10-minute opening remark, I would like to use this opportunity to give you a brief overview of the motivation of this workshop and to introduce this particular invited speakers and workshop schedules. Finally, I would like to use this opportunity to acknowledge all the organizers and the sponsors, which makes a great effort for this workshop to take place. So the motivation of this workshop is a long-term goal of seeking structures from high-dimensional data. As we all know, analyzing high-dimensional data is a tremendous difficult task. In the past, the nice thing that people discovered from high-dimensional data is that high-dimensional data often has benign low-dimensional structures such as sparsity or low randomness. And to exploit this kind of low-dimensional structure, the traditional way is that, first of all, people assume some generative or precise mathematical models of the data. And based on the model assumption using previous informations, people cast the problem as optimization problem. And hopefully by solving some challenging optimization problems, we can learn or extract useful low-dimensional structures from the data. By using this type of idea in the past 2 decades, we have solved many fundamental problems in signal processing and machine learning, such as compressed sensing, low-rank matrix recovery, phase retrieval, superillusion, blind deconvolution, and sparsifying dictionary learning, etc. However, there are some new challenges arise. For example, what if we have no prior information of the data or the structure? What if the data model we are trying to learn is highly complicated and highly nonlinear? How can we deal with this kind of difficulties? The resurgence of deep learning suggests actually we can directly learn the data model by using a highly complicated neural network directly from the data. However, the deep learning in the past have often been viewed as a black box, where we have very limited understandings of when and why deep learning works, and we don't have much statistical guarantees. The goal of this workshop is that we want to utilize the low-dimensional structures to provide better understandings, have a more principled ways for designing and understanding deep neural networks. In the past, people have already found many connections of deep neural networks with the traditional ways that we are dealing with low-dimensional structures or low-dimensional models. For example, in network architecture design, there's a structured connection between deep neural networks and the sparsifying algorithms, where the network can be constructed by unrolling an optimization algorithm for sparse recovery, for example. And this type of perspective have already transformed the ways that we are solving inverse problems. On the other hand, there are many theoretical and numerical evidence suggests that supporting that enforcing certain isometry properties within the network often leads to improved performance for our training, generalization, and robustness. Moreover, the low-dimensional modeling has recently shown as a common use testbed for understanding generalization, implicit and explicit regularization, expressivity in deep neural networks. So to sum up, all those inspires us to organize such a workshop to study the connections between low-dimensional models and deep learning. So actually, in the last year, 2 of my colleagues have already initiated this study where they organized a similar workshop physically happened at Columbia University last year. And 2 organizers, one is my PhD advisor, Professor John Wright at Columbia University. Another is Professor Yuqian Zhang at Rutgers University, who is my academic sister. So the workshop is titled Deep Learning and Low-Dimensional Structures. And I attended this workshop, which is really spectacular, where I learned a lot from the amazing talks. So in vain of this effort, we are organizing a similar workshop this year at almost exactly the same time to pursue this direction and understanding the connections between deep networks and low-dimensional models. So this year, we have some old faces like Yuejie, Carlos, Yi, Renee, John from last year's workshop. And we also have some new faces such like Alex, Tom, Boris, Ruoyu, Chong, etc. And we hope the new speakers can provide some inspiring new perspectives on this line of research topic and open some new directions. So here is a brief overview of the workshop schedule. This is a 2-day workshop, and we have 5 talks each day, where we have, on day 1, we have 3 talks in the morning and 2 talks in the afternoon. And by the end of the day, we have a panel discussion to discuss about the directions pursued to low-dimensional structures in deep networks. On the second day, we have another 5 talks, where 3 talks in the morning, 2 talks in the afternoon. And by the end of the day, the difference from day 1 is that instead of panel discussion, we have a young researcher spotlight talks by the end of the day. Where this year we have invited a diverse and spectacular group of active young researchers in this field, where each of them will give a 10-minute spotlight on their latest work on foundation of deep networks, which is really inspiring and exciting. Here is some participation statistics according to Google for this workshop, where we have over 400 registered attendees. About half of them are graduate students or PhD students, and about quarter are faculties, and there's another 10% postdocs and 10% research scientists. Interestingly, what we find is that actually all of them are interested in participating in both of days of the workshop. Finally, I would like to acknowledge the wonderful organizers, co-organizers of this workshop, which make a great effort for this workshop to take place. And they will show up sequentially when going deep into the workshop, where this morning, Professor Ima from UC Berkeley will appear as a speaker and team leader in this workshop. In this afternoon, Dr. Chongyu from UC Berkeley and Google will be the moderator for this afternoon's talks. And by the end of the day, Professor Jerry Sulam from Johns Hopkins will moderate the panel discussion. On day 2, Professor Zhihui Zhu from University of Denver will moderate the talks in the morning. And Professor Atlas Wang from UT Austin will moderate the rest of the talks and the young researcher spotlight talks for the rest of the day 2. Finally, I would like to thank all the sponsors for this workshop. In particular, I would like to thank the Competition Imaging Technical Committee, which advocates and provides strong support for this workshop to take place. And this workshop is also co-sponsored by Mathematical Institute for Data Science at Johns Hopkins University, Michigan Institute for Data Science and University of Michigan, and Georgia Institute for Data Science and University of Rochester. Thank you for attendance. Welcome.